Hey guys, so today we're going to be looking at compositions and how to solve them when it involves trig functions. So we're going to start off with an example that is not a composition, but it is a basic problem that you should be able to solve if you want to solve compositions. So let's say the question states, okay, so how would we approach this? So first we need to draw the graph. And now we have to see where we would graph the triangle. So the quadrants in which sign can be negative the quadrant is quadrant 4, because the outputs of sign can only come from quadrant 1 and 4, and 4 is the only one in which sign is negative, because our input here is negative 2/4. So let's draw this. And it will be a right triangle. And remember, when we're evaluating the inverse of a sign, the angle that we're doing this process to would be this angle closest to the origin. So now let's label. Let's label the triangle. So at the top here, you can see that I put this little reminder for SOHCAHTOA. So that means sine is opposite over hypotenuse. So it will look like this. And I'm not labeling 2 as negative because it should be understood that it's negative, as you can see the placement in the graph, because it's in the 4th quadrant and it's going down, so it should be understood. And this will be how the triangle will look like. This was just an example to set us up for our later problem. So let's go down. And let's look at the next problem. Okay. So let's draw our coordinate plane. And let's look at this problem. So this is a composition, and when we're solving compositions, we look at the first part, and the first part would be the middle. So, sorry, let me close this really quick. So what I mean is that we would first have to evaluate this inverse cosine of 4/5, and then we would move on to tan of whatever the answer is to the inverse cosine of 4/5. So you have to evaluate the red part I circled first, and then the blue part. So let's draw our triangle. So because it's positive and it's cosine, it will have to be in the 1st quadrant, because the output of cosine can only come from the 1st and 2nd quadrant. So now we have this, we can label our triangle. So let me go back up, and we can see that cosine is adjacent over hypotenuse. So there. And as you can see, we have not finished this problem yet. So now we're trying to find what the tan of this answer would be. And to solve tan, we would need to know the opposite side, so the side that we have not filled out, which is this. So how would we find that? Well, this is a right triangle, so we can use the Pythagoras theorem. So that will look like so it would be 4 squared plus b squared equals c squared. Sorry, we know c is 5 squared. So this is a common Pythagorean theorem problem. So some of you will be able to recognize that b is equal to 3. And even if you're not, you can always solve this by hand or using a calculator. So now we know that this is that. And let's go back to our problem. We want to find tan of this triangle. So tan is what? Let's look. Opposite over adjacent. So the answer would be, the answer to this whole problem would be there. Because this is the opposite, this is adjacent. And to solve this problem, we have to find the inverse of cosine in the beginning, or the inverse cosine of 4 over 5. And then we had to use that answer to find the missing leg of the triangle. Then we had to find the tan of this full triangle. Now let's look at a different composition. This problem is not complicated, but it can be a little overwhelming to some people. Sorry, let me write that a little better. Okay, so you might be a little confused as to why there is not a number in here, but let's see how we would approach that. So once again, we'll draw our plane, and then we want to draw the triangle. So its cosine is positive, so it will be here. And now you have to remember that this is equal to x over 1. So x over 1 equals adjacent over hypotenuse based on our SOHCAHTOA. So that means x will be here and 1 will be here. And now what will this be? Well, let's solve that right here. It would be x squared plus b squared equals 1, right? So then b would equal the square root of 1 minus x squared. So this would be the length of this triangle right here. Sorry. Would be square root of 1 minus x squared. And now we have to find the sine of this triangle. So remember, the angle we are basing this off of is this. So sine would be a opposite over hypotenuse. So the answer would be square root of 1 minus x squared over 1. So this is the answer to this composition.